Kioxia's software-enabled flash nameless copy feature brings host CPU and memory offload capability to flash storage. Garbage collection and wear leveling are storage operations that can consume valuable host resources, including CPU cycles and host DRAM. Manual copy for garbage collection requires the host to read fragmented blocks of data, coalesce the collected blocks in DRAM, write them out to spare block locations, then free up the blocks that have been collected. The Nameless Copy feature simplifies host operations by defining a table of data block locations that need to be moved. The software-enabled flash device will internally manage movement of the data and notify the host when completed. For our demonstration, first we split the software-enabled flash device into two equally sized virtual devices to define flash die isolation. We then create quality of service domains to fill each volume. Software-enabled flash technology is able to use separate FTL tables in each QoS domain, allowing garbage collection to run independently within each volume. The workload is 100% write I/O. The amount of data written is larger than each of the storage volumes, forcing both volumes to perform garbage collection to complete the write workload. As we start the demo, we show two charts with the user workloads, a graph showing CPU utilization, and tables showing the commands used to move user data during the test. Both graphs show a red area for cumulative writes for the user workload. We will now accelerate the video to save time. The blue line in the manual copy operation is now starting to grow, indicating the host read and write operations for garbage collection have begun. The user workload has now completed on the Nameless Copy volume. We will once again accelerate the demo to completion of the manual copy operation. Overall, Nameless Copy has utilized less host resources for memory, PCIe bus bandwidth, time, and CPU cycles by a significant amount by not having to copy data into and out of the host for garbage collection operations. Now the manual copy operation has completed its garbage collection task. The workload is the same for copied and released blocks. The number of host commands issued are significantly different, as well as the amount of data transferred to and from the host, and there is a significant impact on the number of CPU cycles used between the two operations. Kioxia's software-enabled flash technology brings copy offload features to deliver host control, efficiency, and latency improvement outcomes, all while reducing the burden on host resources.